Having done a previous tutorial on adaptive engines in FMOD, I thought I'd do another one here to show how far you can take this concept. In this case, designing the sound of a spaceship engine. Obviously, this is a test of the imagination. We're going to make this engine on the basis of a sum of different components. This is why I've put up a picture of a potential spaceship where we at least have two engine systems, a forward propulsion system and of course an upward or floating system. So this is the kind of thing I was bearing in mind when I set about designing my spaceship engine. Let's move over to FMOD and have a look. So here you can see the final spaceship meta event with the sum of all these different components, which we have broken down here. Here the spaceship takes off. So let me take you through this on the basis of where I started. So first up, in terms of engines, simply put, we have combustion engines like cars, we have propeller engines like biplanes and helicopters, and we have jet engines like rockets and of course airplane jets. And of course we have a fourth imaginary futuristic engine concept. I think I started with the jets. So here we have my jet sound at a constant hum between 0 and 100 RPM, and if we ramp up, so just as a general note for all of my engines, I decided that our spaceship couldn't go below 100 RPM. And so below 100 RPM, we go into an idle jet sound, which is just the same sample, but not auto-pitched to run up and down the pitch range of the RPM. So how did I arrive at this jet sound? First of all, I did some research, and I would highly recommend this book by Andy Farnell called Designing Sound. A lot of it is about pure data, but we can take many aspects of what he's talking about and apply it to other aspects of sound design. He's also obsessed with procedural audio, so if we're going to look at a car engine, he's going to break it down into different components and see how we sonically can reproduce those components and build it back up into an engine. With regard to jet engines, he argues and proves to a certain point that a jet engine is mostly made up of a series of sine wave components. So let me show you here what I did in experimentation to arrive at my jet sound. Here is a jet sine engine made up of entirely sine wave components. Let's just have a listen to them first of all. So they are all the same file, which is originally a 1 kilohertz sine wave, but using the pitch of the containers and different root pitches, I have laid out some different pitches here. So first of all, there we've got two close pitch ranges so that they beat slightly, a lower component, an even lower component, another beating component, and then some high frequency components there. Now that may not sound like a jet engine when you just play it like that, but once we start ramping up and down, so I wouldn't try to argue that this sounds like a great jet engine, but I think what it proves is that when we hear a jet engine, what our ear picks up on are those sine wave components, and in fact, it's the shifting pitch of them that gives us the sense of a jet, rather than the static sound. If we go to my next experiment, And this has a really nice blend, if you like, of sort of lower frequency rhythmic elements, higher frequency sine wave components, but also sort of airy sound of a jet engine just turning over. The full finished jet engine sound. So in my mind, that makes up the forward propulsion element of our spaceship. So what about the part of the spaceship that lifts it up off the ground, the kind of floating aspect? If we go and have a look at my motor component here, this is where I sort of put more sci-fi elements together in place. This is made of two components, a spaceship wobble loop and this rev file here. Let's just listen to the wobble first of all on its own. So you can see there's a low frequency wobble, but a sort of high frequency aim as well. We've got 4 kind of wobbles in one loop. So down there, really low. That's an idle futuristic hovering engine. And there we go. So to add to this wobbly sound, this is a very different way of going about making an RPM range on a sound. So I'm not here using the auto pitch feature. Let's just have a listen to the sound on its own. So this is a sound I made in Native Instruments Massive Synth. It's essentially a low frequency oscillation there, but because of the waveform that I used, or maybe some distortion, we have some high frequency content there in the sound as well. However, we then start to put this through a number of effects in order to get the full sense. So rather than using auto pitch, I've used automation to ramp up and down the pitch of the actual container so that we go from 11 semitones up all the way up to 24 semitones, but it's not just made up of pitch. So if I start off with our idle loop between 0 and 100, what you can hear there is the result of this tremolo and FMOD effect or plugin. And it's creating a stereo spread. You can also see it here in the meters, which creates another nice wobble sound, this time in stereo. You'll also notice that I have some quite extreme filtering going on here because of the high frequency content and the low frequency wobble in the original sound. Using the low and high pass with quite extreme settings, we can create a sense that when we go up in pitch or up in RPM, then more distortion or more high frequency content comes out. So you may notice there that an artifact of this tremolo plugin is that when you automate the frequency, it sort of takes a little bit of time to catch up, as in it can't really smoothly automate that frequency. But I actually think this gives a quite nice sort of delayed effect, and so I've kept it for that reason. However, what I did do in order to sort of cover over it is to add in a pretty long delay line here. So we have a very short delay time, but we have very high feedback, and what this means is that as the engine ramps up or ramps down, you kind of hear the ramp up and ramp down whilst the engine settles into its steady RPM range. So let me play that. It's a little bit strange at times, but again, I think this adds a sort of futuristic element, and it's all about how it ties in with the other sounds. So if we consider this one vertical lift motor made of a futuristic technology, here's how it sounds in total. So that's it when it's idle, floating, still, not moving, and then we're going to take off. So that's the motor or upward lift element of my spaceship sound. The other thing that I felt was necessary here is an engine scream, something that would allow us to really show when the engine is put under stress or when the load on parameter is going to go up, something I'm going to talk about later on. Here I was inspired to do some research into Ben Burtt's sound design for TIE fighters, because it's a very memorable futuristic space-like scream. So after some research, I discovered that the TIE fighter sound was mainly made from the sort of bellow of an elephant's trunk. Here is a raw version of that sound I was able to find on YouTube. So you can hear there's one sort of scream, but Ben Burt has then layered it with a slightly pitched down version of that scream and then a more pitched down version of that scream to create a sort of sense of Doppler effect. So you can take that scream, put it into FMOD, pitch it up and down, you in fact get a very interesting TIE fighter-like scream very quickly. But of course I didn't want to use the same sound. So I experimented with a few similar sounds. Let me just first show you the one that I made from a walrus sample. It's a walrus scream that I collected quite a while ago, and the straight sample sounds like this. So there's an interesting texture there. There's another loop made from the same sample, and another loop there. And so if we listen to these, once I auto pitch these and we move them up and down, so you can hear there's some interesting textures and ideas going on. I wouldn't say any of them specifically work on their own, but if we start to put them all together, I managed to get an engine that sounds like this. I wasn't entirely happy with the sound, but it certainly got me going on fulfilling this idea of an engine scream with something that really isn't made of a mechanical engine at all. It adds an alien-like aspect to the sound. It certainly adds a ferocity to the sound, but it does sound a little bit evil in this instance. If we go back and have a look at the engine scream that I have in my final version, we'll see that I called this the TIE Fighter Dry Ice. I managed to find a sample of dry ice being scraped on metal. Sounds like this. So I've had to sort of create a loop out of a part of a sound, but what we have there is a bit of a screech, something that doesn't really sound out of this world. And if we auto pitch that up and down, then my dry ice engine scream sounds like this. So that's it with no scream. So it's a little bit piercing, but that's very effective once we add it on top of the other elements. So if we go back to my Meta Spaceship engine now, and let's just listen to how this sounds. So what I've got here is a meta event where the sound is going to take off, which is one pre-designed sound that we have there. Then as it takes off, different elements of the engine are going to come in, and we're going to get stuck in this loop here. At this point, the engine will be fully adaptive. The player would be in control of the engine and can ramp up or ramp down the RPM. There's a couple of elements here that we haven't looked at. I've got an engine roar. Let me just show you that on its own. That's actually a pre-designed sound. There's a number of different roars and sounds in there to make the sound up. But the idea here is that we have one element of the engine which does not pitch up and down with RPM. Imagine, for instance, that this is the flame coming out the back of the jet. The jet will go up in pitch. The flame will rise in amplitude or ferocity, but it won't pitch with the engine. What we also have, because I'm imagining our spaceship is flying through an atmosphere, so flying through air or a similar gaseous substance, then of course as we go faster we're going to increase the sound of our wind. So let's just have a quick look at our wind event here. The wind is not affected by RPM, but of course by the speed of the vehicle. And they are related, but not the same, because you can increase the RPM, get up to a high velocity, but of course you can then take your foot off the pedal of the engine and continue at that velocity until the forces against you slow you down. So here's our wind event. At low velocity, we have some wind blowing past, but nothing very ferocious. As we ramp up, in comes a howl. And of course everything gets louder. But when we get above 50% velocity, we start to get higher frequency howling artifacts buffeting around. If our spaceship wasn't flying through an atmosphere, then of course we could just turn this off, and that would be easy to do in the game engine. So what other elements have we got here to complicate things further? What we also have is a load on and a load off parameter. And the idea of here is, of course, difference between an engine that is under stress and an engine that has no stress. And in this case, I did the load on and load off mostly with automation changes that we can see here. So the engine scream that we heard, the TIE Fighter-like scream, will ramp up as the load on increases, and will ramp down as the load off increases. Similarly, the engine roar is automated to do something similar down there. And let's listen to how that sounds. It's more noticeable at higher RPMs. So there we go. There's also minor pitch changes in the load on and load off parameters, so that we hear the engine go up in RPM, if you like, as we turn a corner or go up a steep hill, those kinds of ideas. In addition to the load on and load off, I had the idea, of course, that the spaceship can bump into different things around the level or world. So here we have an impact parameter. Anything above 0 is going to create an impact sound, which means that we're going to hit something. If we go and have a look at the impact here, there's a separate event that's referenced, and here we have that sound. So there's a bunch of different sounds that make this a big clunky sound, but also which make it adaptable and variable. Now, of course, the effect of an impact should you crash into something is relative to the speed that you were traveling at when you made the impact. So if the velocity is all the way down, then of course we're not moving at all, and that makes an impact impossible. However, if we increase the velocity, we have small impact sounds there, and a low chance of debris. If we go up to about 2/3 of the way, the impact is a lot louder, the chances of hearing some debris are much greater, and all the way up to the top. So if we bring that back into our meta spaceship engine here, and let's turn up the velocity. The impact sound gets slightly lost, so we do actually have a ducking feature going on, so that when there's an impact we hear the motor slightly less. Finally, it's often the case in games that we have some adaptive sound design determined by the health of the player, or in this case the player's vehicle. So I have here vehicle health, for which the default value is 100%, but if we start to lower the health, the engine will start to sound worse and worse until when we get very low, we get a warning alarm. Let's just have a listen to that. So below 50% it starts to stutter. Below 20%, it starts to really suffer.
Warning.
There we get a warning alarm.
Warning. 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 Warning.
See the engine suffering there.
Warning. Warning. Warning.
And there at 0, of course, the engine sounding very dodgy, but the game would go through a death sequence, which would be a different event, if you like. On their own, these sounds are quite isolated and sporadic, but if we add it all together...
Warning. Warning. Warning.
So that's the engine falling apart and a sort of added alarm. But if we go back and have a look at the meta system, the other thing that's going on here is that in the vehicle health parameter, I've put some white noise. Now the sound of this white noise is non-existent, but we're using this as a sidechain. So here's the white noise. Sounds like white noise. But if we go and have a look, what I've done here is filtered down the white noise very significantly down to 12 Hertz when we get to really low health. Because it has a random amount of every frequency, that's the definition of white noise, if we filter out nothing but low frequency, what we're going to get is a very random modulation of amplitude. We won't be able to hear it because it's muted, but if we have a look at the sidechain amplitude, we'll notice that with no filtering, the sidechain is of course a constant amplitude signal. As we lower the filter down to low Hertz, we start to get a wobble in the amplitude because the low frequency components are coming in and out. And if we go really low down to about 12 Hertz, then we start to get some really interesting fluctuations in sound. Now what I've done here is use that sort of random wobbly sidechain to affect the volume or stuttering of various elements of the engine, for instance, the motors, the jets, and so on. So let's hear how this sounds as we lower the health.
Warning. 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 Warning.
So what's happening there is that the depth of the tremolo is increasing, so we start to get the stuttering. So here I have a group really that brings together the engine elements, and the sidechain is in fact affecting the frequency of the tremolo. So we get sometimes fast stutters and sometimes slow stutters, and we get a kind of random oscillation between the two, and that's how we get this struggling engine turning over sound.
Warning. Warning.
So there we go. The only element to finish off with all this is, of course, the fact that we add in a takeoff sound. We fade that out nicely. We slowly fade in the different elements of the engine here. And then I have a logical transition region here, which means that if our RPM gets below 0, then we're going to begin the shutdown. So once more, here is my adaptive Spaceship engine. Down to idle. Let's bring down the health.
Warning. 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 Warning.
Let's get some health back. And let's shut down the engine. There you go. I hope you enjoyed my adaptive spaceship engine design. Thanks for watching.